in this video, we're going to be exploring modular blockchains. To better understand modular blockchains, we will first look at monolithic blockchains and then go over how they differ from each other. So, what are monolithic blockchains? If you've heard of Bitcoin, Ethereum, or Solana, then you definitely know about monolithic blockchains. And they are essentially blockchains that aim to handle the core components or features of a blockchain, and they do not outsource any of them. So the core components of a blockchain are consensus, which is the validation mechanism of the blockchain and is either proof of stake or proof of work. We have data availability, which refers to the ability of the nodes to verify the availability of data for a proposed block without having to download it. There's the execution layer, which is the layer that executes all transactions that are then stored on the blockchain. And then we have the settlement layer, which is a final execution layer, and it guarantees the transactions which have been validated are immutable. That is, they cannot be reversed. And so why is there a need for modular blockchains? Let's look at some of the limitations of monolithic blockchains. And monolithic blockchains, when focused on decentralization and security, are able to create secure permissionless blockchains. But the problem arises when they begin to scale and have a lot more transactions, because there's always a trade-off between decentralization, security, and scalability, i.e. the blockchain trilemma. And so we see that Bitcoin and Ethereum have picked decentralization and security over scalability and have very high transaction fees. But we have other blockchains like Solana that made different trade-offs. And so modular blockchains are blockchains that outsource one or more of its components, so that either the consensus, the execution, the data availability, or settlement to another independent chain. And they do this to increase the efficiency of the blockchain by increasing its performance and thus increasing its scalability and allowing it to scale. And so let's look at how this works. It works by using the principle of modularity, which involves separating the system into distinct and specialized components that only do a few things, but they do those few things very well. And then by combining those components in different ways, they're able to meet specific goals. To understand this better, let's look at some examples of modular blockchains and how they operate. So we have Celestia, really popular, really good. And Celestia only handles the data availability, but it decouples the execution and consensus layers. And then we have rollups. Optimistic and ZK rollups help Ethereum to scale, and so they act as the execution layer, but they depend on Ethereum blockchain for settlement, data availability, and consensus. There's Validium, and Validium chains operate in a similar way to rollups, but the only difference is that they don't store the data on the parent chain. And with data sharding and rollups, Ethereum is also able to operate as a modular blockchain. There are lots of benefits of modular blockchains, some of which include scalability, flexibility with design and implementations, and then it just makes it easier to launch new chains, which helps with decentralization. A few cons of modular blockchains are, of course, added complexity. Then there might be security issues just because the security is dependent on the parent chain, and then some chains would have lower token value. Are there any modular blockchains you're really interested in? Let us know down in the comments. Thank you.